Hello, wonderful people. Welcome to today's math class. Look at this question before us here. About a year and a half ago, I solved this challenge and I took time to look at this question again because I formed a habit of going through my old videos to see if there is any error. Okay, and I discovered a very little error, a slight mistake, okay, in that video. So I have to take down that video and I want to reproduce that video and solve it the normal way. Although I got the correct answer at the end, but just because of a line, I just have to take that video down because we are not here to mislead any person here. So the question is m to the power of 4 minus 5 to the power 5 times m to the power of 2 equal to 36. What is the value of m? We have to solve for 4 possible roots to this challenge. Okay, because the highest power of m or the variable is 4. So let's take our solution here. Okay, so you just have to watch from the beginning to the end of this video because there is a special approach I'm going to apply in solving this here. Now, the question is m to the power of 4 minus 5 m to the power of 2 equal to 36, right? Good. Move this 36 to the left-hand side of the equation. So this is going to give us m to the power of 4, then minus 5 m to the power of 2 minus 36 equal to 0. Okay. So with this, we just have to rewrite this m to the power of 4. In other words, I want to bring in another alphabet to represent our m to the power of 2 and m to the power of 4. How do I mean? Now, I want to bring in, I like using t all the time. So let's say let t to the power of 2, or let's just say ordinary t first, okay? Ordinary t, let ordinary t be equal to our m to the power of 2. So, because we have m to the power of 2 represented by t already, so we have to bring in a quantity that will also represent this m to the power of 4, and it must be that same t. And so we go to square both sides. This is going to give us t to the power of 2 will now be equal to m to the power of 4. With this, we want to represent our m here to the power of 2 with t, the m to the power of 4 with t to the power of 2. So rewriting this expression, this now implies our t to the power of 2 minus 5t rather. Pardon, please. So 5t, right? Then minus 36 equal to 0. So what kind of equation is it? This is a quadratic equation, right? In t. So we can use the factorization method to solve this. And how do I mean? We think from the factors of 36, two numbers that when we multiply together will give us minus 36. Their summation will give us minus 5. So let's begin to think. That will give us something 9 and 4. Okay. So but what will now be the sign? It's going to give us minus 9 plus 4. Yeah, minus 9 plus 4. So this is going to give us our t to the power of 2. Then minus, let's take our 9t there plus our 4t minus 36 equal to 0. So from here, we can put this in bracket, also put this and this in bracket. We factor out terms that are common to each of these brackets. Here we have t common. So we have here t bracket t into t squared will give us t minus, we left with 9 here, there plus what is common here is just 4. So bracket here 4 is left out, and here 4 into 36 will give us 9. Close bracket, this is equal to 0. If you check the terms that are inside the bracket, you'll discover that this and this are the same. So what we do, we take this one and this one that is outside and one of these ones inside. So this is going to give us our t there plus our 4 close bracket bracket t minus our 9 close bracket equal to 0. Oh, that's good. So from here, there is a special law we're going to apply, which says that if you have your a times your m equal to 0, it means that your a is equal to 0 or your m is equal to 0. So if either a is equal to 0 or m is equal to 0, we can apply that. So here we can send this to this side, send this to this side, right? Good. But here comes the special trick I want to apply again now. I don't want to do that. Remember what we did here now. So I want to bring in the value of t, not t squared, into this and this. Easy. So if I bring it here and here, what would that look like? Okay, so this is going to give us, this now implies bracket. What is our t? T is m to the power of 2. So we're going to have here m to the power of 2, then plus r4 close bracket. Again, t is m to the power of 2 minus 9 close bracket equal to 0. Do you see the uniqueness of this approach? Yeah. Again, we could as well solve this by equating this to 0, equating this to 0. But I said I don't want to use that method. Let's get something fresh, something new. So, because this is to the power of 2, this is to the power of 2, 4 is a perfect square, 9 is a perfect square also. So let's go ahead and rewrite this. So this is going to give us our m to the power of 2 plus 2 to the power of 2 close bracket, our m to the power of 2 minus 3 to the power of 2 close bracket equal to 0. Here we have what we call difference of 2 square. We all know difference of 2 square, right? What does it say? It says that if you have your x, okay, if you have x to the power of 2 minus y to the power of 2, this will give us our x plus y close bracket, our x minus y. We all know this, right? Good. We also have what is called sum of 2 square. What does sum of 2 square say? It says that your x to the power of 2 plus your y to the power of 2, this is equal to, because we can rewrite this expression here by bringing iota. We know that the square root of minus 1 is equal to iota, so we can bring that into this system. And if we do that, this is going to give us bracket your x plus iota y, then bracket your x minus iota y. How? I believe you've seen this before now. So we want to rewrite this using sum of 2 square and this other side using difference of 2 square. So with that, this is going to give us our m, then plus our, let's write the figure first, which is 2 iota bracket our m, then minus 2 iota, right? Then we come to this side, yeah, this is going to give us our m plus our 3, then bracket m minus our 3 equal to 0. Okay, so we have our 4 roots playing out here now. 1, 2, 3, 4. Now, look at this law here. We're going to apply this law. Equate this to 0, equate this to 0, equate this to 0. So it means that the first one we're going to have m plus 2 iota is equal to 0, or m minus 2 iota is equal to 0. Then the second one, we're going to take this to 0, take this to 0. So this is going to give us our m plus 3 equal to 0, or our m minus 3 is equal to 0. So quickly send this to this side to give us minus, this to give us positive, this to give us minus, this to give us positive. So what are the values of m from here? It is clear. So this now implies that our m is equal to minus 2 iota, then or we have our m is equal to positive 2 iota. Down here we have our m is equal to minus 3, then or here we have our m is equal to positive 3. So let's bring that out in a well-organized form. So we're going to have here our m1. Let's take the positive one. So we have here 3. Then our m2. Let's take the negative minus 3. Then our m3 is equal to, let's take the positive imaginary part. So we have here iota. Then our m4, this is equal to minus 2 iota. All these values satisfy the original equation. So these are the values of m that actually satisfy these fourth power or fourth degree polynomial equation. Thank you for watching. Any question, drop in the comment section. We'll see you in our comment section. Thank you for being there. Thank you for watching. We love you. Bye.